What you do? Bridge, building, road. Okay. What you do? Plane, helicopter. Okay. What you do? Okay. What you do? Okay. I want to be engineer. Which one? Saying you want to be an engineer is kind of like saying you want to be an athlete.
What the fuck
Does that mean? So, as per usual, I'm going to break it down for you. Let's dive in. Engineering is the application of science, maths, and logic to design and build things that solve real-world problems. Bridges, buildings, software, power grids, phones, planes, pharmaceuticals, rockets, robots, sex toys, robotic sex toys, all the important stuff. Pretty much everything that makes modern life possible, an engineer touched it. You can think of scientists and engineers as two sides of the same coin. Scientists figure out how the world works, engineers use that knowledge to build stuff that actually does something useful. Think about how many engineers have had to design and build something in order for you to watch this stupid video right now. Some built and designed the power grids, then there's the internet, and the internet's only valuable if we've all got devices that are connected to it. Then we need YouTube to be built and maintained. We also need video editing software, and maybe you're listening with wireless headphones. And very quickly, you can see how basically every single aspect of your life has been touched by an engineer. Thanks, nerds. Now, just like in our quant video, not all nerds are made equal. So in order to understand each nerd and their specialty, I'm going to use a real-world engineering project to explain what each nerd is responsible for. Elon wants to send people to Mars. That means we need to build a rocket big enough to carry the people and all the equipment. We need a launch site strong enough to support it, a life support system that keeps everyone alive for the entire flight, and infrastructure on Mars that lets them stay there. This is how that gets built and which engineers are needed to make it happen. Here's our team for this. Mechanical Mike, Aerospace Angie, Electrical Ellie, Chemical Caitlin, Mechatronic Mary, Civil Cyril, and Software Sally. You might have noticed that 5 out of 7 engineers in our example are women. They would obviously be trans women, seeing as most engineers are male. Anyways, first up we've got Mechanical Mike. Mechanical engineers design, build, and test anything that moves or uses mechanical power. So they're working with things like thermodynamics, materials, and fluid mechanics to solve physical problems across almost every industry you can think of. So Mike and his team are responsible for 4 big things here. 1. Structural design. 2. Thermal systems. 3. Landing mechanisms. And 4. The cabin and interior layout. What does this actually mean? I'm glad you asked. So, structural design. Imagine stacking a bunch of Legos on top of each other into a super tall tower, then shaking it as hard as you can, throwing it into the sky, and slamming it back into the ground. That's kind of what happens to a rocket. So Mike and his team is going to have to make sure the rocket is strong enough to hold all its parts together even when it's under huge pressure. They'll also need to run tests to see what happens when it shakes, bends, or twists, because the rocket's definitely going to do that when flying. And now it's time to decide what materials to use so the rocket is both strong and light. Too heavy and it won't get off the ground, but too light and it'll break into a million pieces. Okay, now thermal systems. So space is super cold, like minus 270 degrees Celsius cold. Or again, minus 455 degrees Fahrenheit for you idiot Americans. Anyways, space is cold, but rocket engines are really hot, and electronics hate both. So Mike's got to figure out how to manage all this. They'll install heat pipes and radiators to move heat away from stuff that gets too hot. They'll use special blankets to keep other parts warm, kind of like a space sleeping bag. And they need to make sure the astronauts don't freeze or cook inside the rocket even when it's 3,000 degrees outside during re-entry or minus 270 in space. Now, if we make it all the way through space and all the way to Mars, but then when we land we all blow up and die, what the hell was the point? So our rocket needs to land like a ballerina. Mike's team will need to design and build the landing legs for the rocket, and we'll have to test it over and over again to make sure nothing snaps even if it lands a little hard. And finally, we've got the cabin and interior layout. At the end of the day, we're transporting humans in this thing. They need a safe, comfortable-ish place to sit, sleep, breathe, and not die. So Mike's team will help build the inside walls, floors, seats, and everything else, making sure they can handle pressure and high G-forces. They'll also make sure there's a safe amount of oxygen and that air moves around evenly, and they'll need to add special doors and emergency exits in case we shit the bed. Basically, if it's a physical part of the rocket, mechanical engineers are the ones who figure out how to build it. Now, Aerospace Angie and her team. These guys specialize in anything that flies. Planes, helicopters, satellites, drones, rockets, and space stations. They focus on aerodynamics, propulsion, flight mechanics, and structural design. So for our rocket ship, aerodynamics is going to be a massive one, and is going to affect 3 key areas, being drag, stability, and structural load. If Angie doesn't handle the aerodynamics properly, then we're going to have way more drag than necessary, not enough stability to maintain our flight path, and the structural load will be way too inefficient. Then we've got propulsion. they're not going to be the ones building the rocket engines. That'll be the mechanical and chemical team. But they decide how the rocket uses them. So they'll calculate how much thrust the rocket needs to escape Earth's gravity, they'll help control when and for how long each engine fires, and they'll design steering systems that use tiny rockets called thrusters to change direction. Flight mechanics is all about making sure the rocket flies like it's supposed to. Imagine you're throwing a paper airplane across a room. Fold it properly and throw it right, it'll fly great. Fold it like an idiot and throw it like a retard, and it'll crash almost immediately. So they're worried about things like how fast it should go, how much it should turn or tilt, what happens if the wind pushes it sideways, and how does all this change as the weight of the rocket changes mid-flight as it burns fuel. Or for instance, here's a hypothetical. Imagine Lizzo's on board this rocket. Which would never happen, by the way. For one, they don't make spacesuits that big, and two, she'd eat all the food on board. But anyway, hypothetical. What if she was chilling on the left side of the ship and then suddenly moved over to the right side? The physics of the rocket has changed dramatically, and Angie needs to be able to deal with these kinds of dynamic problems. And finally, we've got structural design. This is where Angie and Mike will be working side by side. Mike's got the generalized expertise for mechanical systems, Angie's got specialized mechanical knowledge with regards to shit that flies. Next up, electrical Ellie. Electrical engineers deal with electricity in all forms, from massive power grids down to tiny microchips in your phone. So Ellie's job is to make sure everything turns on, stays on, and talks to each other, even when we're millions of kilometers away in outer space. So a team needs to handle the power systems, communication systems, sensors and electronics, and safety systems. Every part of the rocket needs electricity. Lights, computers, engines, air filters, heaters, even the coffee machine. And so Ellie and her team are going to need to build a pretty robust battery system that's connected with a bunch of circuits and wires to every corner of the ship. They'll also need to make sure that the batteries don't overheat, freeze, or explode. And what's one of the key areas those batteries are going to power? Our comms system. So they'll need to build giant antennas and radios that can send messages across millions of kilometers. And they'll need to be protected from things like solar flares or cosmic rays. Now, in order to understand what's going on with the rocket, we need sensors and electronics everywhere. We're checking things like temperature, pressure, fuel levels, vibrations, oxygen levels, literally everything. Ellie's going to have to design, build, and connect up all these to the rocket's brain so that the software knows what's going on. Without sensors, the rocket is flying blind. And then we've obviously got all the boring safety systems. But that's gay, so we'll move along. Chemical Caitlin, you're up. Chemical engineers turn raw materials into useful products by designing and optimizing chemical processes. And they work on everything from fuels, plastics, and pharmaceuticals to food, cosmetics, alcohol, and cleaning products. It's kind of like a perfect blend of chemistry, physics, and biology with a ton of maths. So if you've ever watched Breaking Bad and thought that being the next Heisenberg would be pretty cool, studying chemical engineering is a pretty solid foundation.
Actually, it's just basic chemistry.
So, for our rocket, they're going to be in charge of rocket fuel, air, water, and waste, and resource utilization. Honestly, really important stuff. The rocket fuel, we obviously need that shit. But the air, water, and waste systems are where shit gets really interesting. For instance, what if someone farts in the spaceship? Where's that going to go? And what if someone gets sick and coughs everywhere? Is that bacteria going to be inside the ship forever? And where's all the pee, poo, and sweat going? All jokes aside, they've legitimately got to answer these questions and then build systems to solve the issues. In fact, you'll probably be recycling that pee and sweat into drinkable water. Efficiency. And their other big responsibility? Resource utilization. You can't bring enough fuel to also get back from Mars. It's just too heavy. So, we have to make it on Mars. How? Go study chemical engineering and find out yourself. The specifics are too deep for this video. But yeah, Chemical Caitlin's team, super important. Next up, Mechatronic Mary. Mechatronics engineers are hybrid engineers who combine mechanical, electrical, and software systems to build intelligent machines. They're the ones behind automation, robotics, drones, and advanced manufacturing systems. They're basically just wannabe Tony Starks who think they can do it all. And Mary's team is going to be a massive help with the manufacturing process before liftoff. They'll design robotic arms that'll be used to do things our tiny meat arms can't, like weld parts of the rocket with extreme precision or lift and move heavy pieces into place. And that's before liftoff. After liftoff, they're also going to be a tremendous help once we arrive on Mars. For instance, we can't send humans out first. Too risky. So we send robots. And think about all the different engineering aspects of robotics that these guys have to cover. You've got the mechanical moving pieces. What kind of motor are we using? What wheels do you use? What's our gear setup look like? Then the electrical stuff. What battery are we going with? What sensors do we need? And which specific components do we select for each? And finally, the software side, getting it to actually do what we want it to do. Turn right, turn left, change camera angle, yada yada yada. They're also great to have on complex engineering projects because they can talk to other engineering teams, mechanical, electrical, and software, and understand what each is talking about. Anyways, onto boring, Cyril civil engineer. Civil engineers are the ones who build all the big shit in society. The stuff we walk on, drive on, and live in. Roads, bridges, buildings, airports, tunnels, dams, pipes, towers, all of it. So Cyril's not going to be the one building the rocket. He's going to be building everything around it that makes the rocket possible. Things like the launch pad, it's got to be able to withstand tons of weight and insane heat from the engines. Then you've got the cooling systems and these things called flame trenches. And these make sure that when the rocket takes off, the fire and sound from the explosions don't bounce back and destroy everything. And they'll even have to make sure the roads and towers are strong enough to carry giant rocket parts, tanks, and fuel trucks. Once we get to Mars, Cyril's team are going to be the key guys setting up our base, picking the best spot for a landing zone, building roads and pathways for our rovers and robots, testing the Martian dirt to make sure it can withstand the weight of our buildings, building foundations that won't crack in the freezing cold or fall apart during dust storms. All in all, they're the ground team, literally. On Earth, they build the pads and towers that let the rocket launch, and on Mars, they build the base that lets the humans survive. And finally, we've got Software Sally. You probably think of software engineers as the guys who build the apps you use. And you're not wrong, but they're also everywhere in modern life. Software's in the cars you drive, the planes you fly, sometimes even the toilets you flush. So of course they're going to be important for our rocket project. First up, they're writing code for the flight computer, the rocket's onboard brain. And that brain controls everything. When to fire the engines, how much fuel to use, how to tilt and steer, when to deploy landing legs, what to do if something goes wrong. And remember all those sensors we mentioned earlier that Ellie and her team designed and built? Well, until Sally programs them, they're still just dumb pieces of metal. And then there's the thousands upon thousands of simulations they'll have to complete. We can't just test a rocket for the very first time out in the real world. Obviously. So we build simulation software with real-world physics and as accurately as possible build a simulated version of our rocket in there in order to test a bunch of different scenarios. Sally's responsibilities that I've touched on is honestly not even close to being exhaustive. You've still got all the software being used back on Earth, the autonomous monitoring systems within the ship, the rocket's autopilot system. It's honestly endless. Software touches everything. So, you want to be an engineer. Now what? Well, you pretty much need a degree. Unless you're planning on being a software or maybe mechatronic engineer, you're gonna need that piece of paper. Here's how to stand out from the rest of your peers though. And as always, it's projects. Start building shit. Gain real-world experience and knowledge, and bonus points for documenting your journey and building up a following on YouTube. Here's some engineering channels I've literally binged for hours. Project Air is perfect for aerospace engineers looking to dive into some of their own projects. Will Cogley is the same for mechatronics dudes. Electro Boom is the absolute best for electronic stuff. Practical Engineering is the best for civil. Real Engineering and Mark Rober are good for everything. Michael Reeves and I Did a Thing are good for chaotic, crazy shit. For software-related stuff, there's a massive amount of content out here, but my favorite to keep up to date on tech trends is Fireship. Mosh if you want some great and easy-to-follow tutorials. Free Code Camp too. So now what? Now you like, comment, subscribe, and wait for the next video.